Howdy. So, interesting job here. I have this VW cluster. I think it's from a 2012 Passat, and I thought I was just going to be making a key to it, but I've done that, and now what I'm running into is that it's not recognizing the key. So, like if I go here, like I've already done the key, I already programmed the key, and now I should be able to enter back into service mode with the key, and also we should see some information there. And I'm not able to, so the key's not reading. And real quick, before I had turned the camera on, I was checking the antenna, to see if it's getting signal. So right now, when I turn the switch back on, we should see this LED light up, and we do not see anything. So there is something wrong with the cluster that is not letting the antenna turn on. So I wanted to investigate that with you guys, um, to kind of see what that problem is. I haven't really messed with it too much, other than just making the key and seeing that that's not working. But let's go ahead and take it back apart here. Okay, so I'm gonna disconnect the display here. Okay, let's get this guy off. And we're just gonna set this out of the way. So let's take a look at this thing here. I don't remember the pinout offhand. I do have it on the computer, but I think we can probably figure it out. I'm pretty sure the VWs are very similar, and here I already see it. This is the typical RFID reader setup on Volkswagen clusters here. So the antenna just comes straight into the connector, and it goes through these filters here. I guess they're little inductors. So you have one side of the antenna coming in, then you have another side of the antenna coming in. And then the driver chip goes somewhere. I have never really dove past this too much. I did have a buddy a couple of weeks ago that run into the exact same problem on a '07, and he was messing around with all this stuff. I think he replaced this chip. I think he tried replacing the crystal here, and he never could get it figured out. I think he ended up replacing the cluster, and we'll probably end up doing the same, but I want to see what this is causing this problem. I want to see if it's something to do with the driver chip, or if it's whatever else is controlling this driver chip. And just looking at this board, I really don't see anything else it could be controlling this except for the main processor. There's like no secondary MCUs, or there's really nothing else that could be doing it. So I'm going to assume that the input comes in, and the controlling for this is straight over here somehow. And we might end up tracing that out. So let's kind of dig in. Maybe we can figure it out. Maybe we can fix it. Maybe not. Let's see. Okay, so the first thing I want to do is I want to solder a couple of just little things here I can connect some oscilloscope probes to. I'm just going to use some solder for that. Solder makes really good quick wires. Okay, so I'm just going to come in, and this is where the antenna input comes in. Okay, there's one. There's two. Just going to put two little things there to hook my probes to. Let's see here. Let me grab my probes. Which one is this? This is blue, so let's do blue on this side. Okay, let's do red on this side. Should already be grounded. I don't think I need to ground it again. Okay, and we have power on already. I don't have it ignitioned. I have the power on my power supply there anyway. I guess I need to plug it in. Okay, let's plug it in. Let me turn on the oscilloscope for you guys so you can see it. And let's turn it on now. Oh, you know what? I didn't have this going. And let's set it. Let's set a trigger just in case it's a quick signal and we miss it. I'm pretty sure it's going to be a pretty big signal, but let's just set it at 4 volts. You know what? Let's set it to 2 volts. And let's just do single. That should be fine. Okay, everything running? Yeah, it's running. Okay, so I'm gonna go ahead and power it up. And we got something a little bit higher than I was expecting. Let's cut this back off. Let's try that again. Let's make this a little bit bigger so we don't get I think that was just from noise. Let's try it again. Yeah, this time it didn't trigger. So I think that was just a little bit of noise. Let's turn the trigger off. Yeah, right now it's just completely dead. So I'm gonna turn it off. I'm gonna turn it back on. Yeah, I don't see anything but noise there. So we have no signal at all coming from the driver chip. Okay, so I'm going to disconnect this from there, disconnect this one from there, and let's pull up the data sheet for this. Now this part number is weird. The part number that's on there is not the part number that it actually is. But give me 1 second. All right, so here is the data sheet. And here we can see what we're working with. Okay, so here, where was our input? So this is our input right here. And it comes into 3 and comes through a capacitor into number 6 and also number 8. Okay, so we have a ground at pin 1. What is pin 2? Pin 2 looks like it goes to the main processor. We also have 14, which is coming from the main processor. Then we have mod out to the processor and then mod into the processor. We have 5 volt supply right here at pin 7. I guess that's an easy thing to check. Let's check that. Let me see if I can make this a little bit smaller. You know what? Let me actually get rid of this and just put up a photo of it. Okay, so I have a little image there of the pinout. And let's go ahead and check through this little guy. I'm gonna turn on the scope here, I can see a little bit better. We have pin 1 kind of down here at the bottom of the screen. And the first thing we want to do is we want to use our oscilloscope here and we're going to check for 5 volts coming in, which checking the pin out there, we can see that it is pin number 7, which we have a nice fat trace and we also have a little test point there to use. Okay, and now I'm going to power on the device and we have nothing. So we do not have any supply voltage going to the RFID driver chip there. And if we follow this fat trace, we see it come over here, comes also into pin 4, so it comes into 4 and 7. They're both power. All right. Okay, we come here, and this looks like it was supposed to have a component, maybe a fuse. Looks like they opted to use a trace as the fuse instead, because you can see it's a little bit smaller. I'm guessing that's what's going on there. Don't know for sure. We follow this fat trace here. We have a through hole going somewhere. Come to this side. We have another test point. Still nothing. And we have a capacitor. And we have our output on this little guy here, which we have nothing. This middle, we got nothing. Well, I don't have it back on. Let's turn it back on. Oh, I do have it on. So I have nothing on anything. Oh no, we have 12 here. Okay, we got nothing there. Okay, so let's find out what this chip is. I guess it's some kind of MOSFET or some type of regulator. This is going to be the output and this input. I tell you, let's check the data sheet one more time. And see what kind of voltage we need to run this chip. Because this, if it runs at, battery voltage, then this may be a MOSFET. Maybe it's just not working. Let me see. I don't remember. I didn't look earlier. So this is a read-write analog front end for 125 kilohertz RFID base station. Previously named P4095. CMOS integrated transceiver circuit. It's used in car immobilizers. Well, that's exactly what it's being used in. So actually, it looks like it is run by 5 volt. So this must be some type of regulator because we have 12 volt going into it. So we're going to have a stable 5 coming out to run this chip. Let me see if I can pull up the data sheet for this chip here. Let's take a look at it again, see what the part number was. Part number is 4266G. All right, did a little sleuthing and found the data sheet for it. And it is a linear 5 volt, 10 volt low drop voltage regulator. Okay, let's see what kind of pinout we got here. So there's the block diagram for it. Not too concerned about that yet. Okay, so we have 1 is the input voltage. Go back. We have 1 is the input voltage. We have 2 is the inhibit input. And then we have Q, which is the output voltage. So, and it's supposed to be on a capacitor, which it is here. And 4 we have a ground. So 2 and 4 are not internally connected. They're two different pins. Supply voltage is negative 42 to 45 max. So this is going to be taking the battery voltage, and then it's going to get the control signal from the processor chip, the main processor, because you remember when we were talking about the input and output for the RFID driver, we noticed there was no other processor chips on the board that could really control things. So that means that this chip is also going to have to be controlled by the processor on there. It's just not nothing else, really there to do it. It's just a bunch of passives. And let me see, I see a CAN transceiver, and that's about it. I mean, there's really just not much to this thing. But anyway, let's see if we can give it some kind of signal, a logic signal, to see if it comes on or not. So I'm going to do just like I did before. I'm going to solder me a little piece of wire. Solder me a little piece of wire. Let's just come to this capacitor here. Okay, and I'm just doing that just to clip my probe to so I don't have to hold it. Okay. And I don't want to cover up the input. Okay, so I have a test point there for the input. And I'm going to use a logic probe. Wait a minute, wait a minute, wait a minute. I'm doing the wrong thing here. I can just clip on these, actually, to see if it works, if I power it, right? I don't need to see my logic signal that I'm going to send it. If I had more probes, I probably would, but my picoscope, I only have 2 probes, and then I have, the MSOs. I'm not going to hook those up, though. But I do want to also check to see if the 5-volt comes on. That's the thing I meant to solder that wire to that I didn't. So I'm going to have to move that, but that's okay. And so you just want to heat it just a little bit, and you just want to hold it in place. That one's pretty good, but I think it would fall apart soon. Okay, that's good enough. And now I'm going to hook this here. Okay, so this one we should see 5-volt. We should see 5-volt when I give it a logic signal. All right, so I've got the signal generator hooked up. This is just a 50 megahertz square wave at 5 volts. Is what I have set up. I think that should be good enough to see. That's just what was already set up. So when I put it on this logic control, we should see 5-volt come on if this chip is working. And let's also see our oscilloscope probes. I have them hooked up to the ins and outs for the antenna. So let's see what happens here. So we are getting something. So that means our regulator is not bad. Man, I was hoping the regulator would be bad. That's actually bad news for us because that would have been easy thing to fix. Whereas what's going on now may not be. I have no idea what these signals are doing or if that's what they should look like. But I don't think that's what they should look like. And I'm sure that when this thing gets sent a signal, it's just a direct signal. I doubt that it's much of a square wave. It probably just comes on solid for like 5 seconds to activate this chip to read the key, and then when it's done, it probably shuts down. So let's investigate that. So I'm going to take this off. So I no longer have the meter hooked up. I'm checking my signal in, which is the blue trace. I'm checking that for the input that I'm sending, and the red trace is going to be the output of this regulator. Yeah, and they're both triggering on high, so you can see the output takes a little while to cut off there. Maybe this frequency is just not good. Let's try to turned off the frequency. I was trying to make it a little bit slower so we could just see a little bit more. There we go. Yeah, man, that takes a while to cut off, doesn't it? Anyway, okay, so that part is okay. So that means that whatever is supposed to be sending the signal is not sending the signal. And like I said, there's just nothing else on here other than this chip that could be controlling that signal. Um, I mean, I'll go ahead and I'll trace it out just so we can 100% can confirm. Maybe it goes through a resistor and the resistor is cracked. Um, or maybe it's got a bypass capacitor or something on there and that is bad. But if all of that is okay, then we're probably looking at software issue or hardware issue with this processor here, unfortunately. All right, so let's follow this trace here. I got my meter set into continuity mode. Got my probes ready, and we need to find the turn on signal for this regulator here. I don't think there's going to be much hope here, but let's try it. So if you look here, we can see the trace going to this capacitor, goes to this test point, goes here, and then it goes to this through hole. And that's as far as we can follow it on this side. So I'm going to see what happens on the other side. Okay, and I found it there. So it is this one. Okay, and it's actually looping away from the microcontroller. So maybe we can find something that proved me wrong. Okay, this going way over here to this resistor. And this resistor is a 1000 ohm resistor. Let's check it real quick. Now I'm going to check it two ways. I'm going to check it on top of the resistor, right? And this is to see if it's good, and it is good. And I'm also going to check it from this point to the hole. Okay, and the reason I checked it like this is to see if it was loose. So it's not cracked at all. It's not a loose joint or anything like that. So that is unfortunate. But the signal did go through a resistor like we were hoping. So that's something. A little bit of good news. See, it goes over here. Actually, it goes under this resistor. And if we keep following it, it should be this trace right here, which now we're going back over towards the main processor. Man, it goes way the hell over here. It's going to be one of these. Let's find out. So let's go back here. I'm going to put this back into continuity mode so it beeps at me. And let's see, it was one of these, right? No? Did I follow that wrong? Yeah, I must have followed it wrong. Let's follow it again. So it's this one that comes under. It's this one. Oh, it goes up, up, up. Yeah, that should be one of these. What am I missing here? Do it one more time. So here, 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 here. It's this top one. It's this top one. It's this top one. It's not this. Oh, I'm an idiot. It is this one right here because it's it goes through that 1K resistor, and if you look at the meter there, you see it's 1,000 there. So if I come here, it's gonna beep. There we go. I'm knucklehead there. All right, so we're gonna check the other side here. So if we look at this cluster, we see it's 3, and there's 3 there. I'm just gonna flip it, and we're gonna try to find that right area, and I did. It's right there. So now I'm gonna flip this way, and it's this one I got here. Now this is probably gonna be the home stretch over to the processor because I can already tell it's going that way. So if we follow, well, how many is that up? 1, 2, 3, 4, 5, 6. It's a 6 up. Are we still in this row? 1, 2, 3, 4, 5, 6. Yeah, so we're still in this row, and it's right there. You see, by counting the position, we know that it was still going this way because this was 6. And sometimes that works, and sometimes it doesn't. Sometimes you got to add in extra rows as you pick them up. But so now we flip back to the other side, and this one was pretty easy to find, I thought. Okay, it's this one. It was this one, which if you count 1, 2, 3, 4, 5, so you come here, and as you can see, we drop 1, we drop 2, we drop 3. So this should be the second one. So we're following the second one. But then there's 1, 2, 3, 4, 5, 6 under it. So you have to count all of that. But then we drop 1. So it's going to be over here. It's going to be one of these. All right, gotta be. No? There it is. Okay. So now we flip it over. There's this one, and this has a test point. Oh, look, we go through another resistor. Maybe this one's the bad one. So we have a test point here, and then we have another 1,000 ohm resistor, and it doesn't appear to be loose. No, this one's reading 1,000 too. You see that? Have another test point here, and this test point goes straight to the processor. So just like we were afraid, this definitely goes straight to the processor, which is bad news for us because that means that either the processor is bad or the programming is bad. So there's probably not much hope to fix this. I mean, you can replace that, but this cluster itself is probably the same price as just trying to buy that chip. Um, and for the most part, this was working. Like I already got the EEPROM data off of it when I was making the key. But what I'm actually going to do is I'm going to put it back into service mode. I'm going to read the EEPROM data again, and I'm actually going to read the flash because VVDI allows you to read the flash. So I'm going to read the flash and the EEPROM, and I'm going to write that to a new cluster. And that will tell us, it will do two things for us. It's going to tell us if it's a software issue, because if it's a software issue, it will move to the other cluster. If it's a hardware issue, then the other cluster will work perfectly. And it carries all the original information to the new cluster, so then I won't have to program it when I put it in the car. It will still be plug and play. Just like if, I was fixing this one. Unless it's software issue. And then if it's software issue, I'll have to figure out if it's in the EEPROM or if it's in the flash. And if it's in the EEPROM, then I'll have to, hack immobilize the data from this one and kind of splice it into the other one there. But I have a feeling it's probably hardware failure. Maybe this this chip ended up failing briefly, and it sent 12 volt into the processor. And these guys, they don't handle 12 volts well at all. So if it 12 volts goes in, or battery voltage, whatever, if that goes in, then it usually fries them. But I'm gonna go ahead and get service mode again. I don't know how much of that I'll film. Maybe I'll film it and fast play it, because that's kind of not what the point of this video was. The point of this video was mainly just to investigate this circuit, which I feel like we've done. So maybe I'll just end this video and do a part 2 when I swap to the other one. I don't know. Anyway, if you guys can think of any other reason, or if you have had this issue and have fixed it, leave a comment. Let me know. Uh, Maybe I'm wrong. Maybe it's not this chip or the programming. Maybe this chip is sensing something else wrong and saying, hey, don't turn it on. So maybe there is hardware failure somewhere else on the board. This chip sees that and think that something is bad, so it's saying, hey, don't start, which is very possible. I don't know. But if you know, let me know, and then we'll both know.